This time I will solve an example of surface friction. So this example is here. The weight of this block is 200 pound and I will pull it that way. My coefficient of static friction is 0.30. Coefficient of kinetic friction is 0.2 or 0.20. Whatever you say is okay. Now the question is, what is the value of friction? What is the value of friction force when my pull is 0? That means when I am not pulling. In that time, what is the frictional force? Second is, what is the frictional force when my pull is 50 pound? That means when my pull is 50 pound. Third case, what is the value of the frictional force when the pull is 60 pound? And finally, what is the frictional force when my pull is 100 pound? So there are different cases. Yes, in your FE exam or in your class, you might get different. You might get any one, not all, because if you can solve one, you should be able to solve all as long as your concept is good. Okay, so if I pull that way, that means my motion intends to be that way. So my frictional force will be this way. So that will be my frictional force. So frictional force. Now we know that the frictional force depends on the weight of the reaction and the surface resistance. That means my frictional force will be Ff mu s times r. Now this is not the frictional force. This is the limiting value of the friction. That means if my applied force is more than this, then my body will start moving. If my applied force is less than this, my body will not start moving. Okay, so what is the value of R? So at the beginning, if I take summation of Fy is 0, so R is, say upward is positive, my R is upward, minus 200 is downward pound. There is no other force in y direction. So my R is 200 pound. Then what is the limiting value of this? So mu s, because at the beginning my body is at rest. So mu is 0.30 times R is 60. Oh, no, R is 200 pounds, sorry. 200, that means 60 pound. So this is not the value of the friction. It is the value of the limiting value of the friction. Okay, now, so we got the limiting value of the frictional force, which is 60. I will erase this to save some space. Okay, maybe sometimes later. Then, what is the value of the frictional force when my pull is 0? That means this value is 0. Then what is the value of frictional force? So as my pull is less than 60, so then my frictional force will be whatever is my pull. So my pull is 0. So answer of the A will be, my frictional force will be 0. At the beginning, I have no friction because I am not pulling it. As I am not pulling it, the body is not moving. As the body is not moving, there is no friction. So at the beginning, my frictional force is 0. Case number 2. What is the value of the friction when my pull is 50? Now this 50 is less than 60. That means still my body is not moving. Still my body did not get the frictional force of 60, because in summation of x should be 0. Whatever the value, that should be the value here. As my body is not moving, that means this value and this value, they are equal. They are in equilibrium condition. The body is not moving, that means it is in equilibrium condition. So case number 2, what is my frictional force when pull is 50? So F is 50 pound, because my body is in equilibrium. It is not moving. So whatever I am applying this way, it is resisting that way. This is why the body is in is at rest. Third case, what is my frictional force when my pull is 60? So this 60 equals to the limiting value of the friction, exactly equal. That means my body intends to move, so if I take the summation of fx is 0, this pull and this will be equal. So case number 3, my frictional force will be 60 pound. That is the limiting value. After that, my body will move. Case number 4, when my pull is 100 pound, what is my frictional force? Yes, so this 100 pound, you can see it is greater than 60. That means my body is moving. My body is moving. If my body moves, what is the frictional force? Mu k times r. Mu k. So mu k is 0.20 and reaction is 200. That means 40 pound. So when the body is moving, the frictional force is 40, no longer 60. Okay, so maybe erase this portion, or maybe you do not need it anymore. So if I write the answer, this will be 0, this will be 50 pound. So make it clean. So hopefully you understood the problem. The misunderstanding you get from your high school is that frictional force is always mu time r. No, it depends on your pull force. If your pull force is less than the limiting friction, then the body is not moving. If body is not moving, your pull and your friction both are equal. Once your applied force is greater than the limiting value, the body will start moving. That time your friction will be mu k times r, no longer mu s. Now, if the problem doesn't give you two values, only one value, that means in that case, the coefficient of static friction and kinetic friction can be assumed equal. But most cases, or I think in all cases, this value is less. Kinetic friction is less. The reason is when the body is in motion, the interlock between the surface and the body is like high. When the body moves, the interlocking is likely to be less. So to my logic, this value is always smaller. Okay, whatever the case is, that will not be a confusion point. Your confusion point will be here. Sometimes people will see that in this case or in this case or in this case, all three cases, I know that student will write frictional force is 60 pound, which is not. Yes, because if I apply summation of fx, it must be in equilibrium. Summation of fx should be 0. So be careful about it. And also here, be careful because the body is in motion. That time mu k, not mu s. Okay, so I will stop here. In next video, I will solve another example. Thank you.